right, as we started page 16 in your textbooks, you did numbers 1 through 10, and then the evens 12 through 24. Have that out so I can check. Yes, sir. If they're on the second column. I was looking at first as well. Thank you. Good. Good. Well, I don't know how else to say good. Yep. All right. Let's take a look here. Numbers 1 through 4, order of operations. Of course, first thing we want to take care of order of operations class is grouping symbols. Good. Parentheses or grouping symbols, the better answer. Second thing, exponents. Third, multiply, divide. Fourth, add, subtract. Number 1, what was your answer, Audrey? 27 is correct. Number 2, Genesis.
I got negative 14 without
Yeah. Negative 39 is our answer to number 2. Number 3, back to Genesis 4, redemption. Ooh, Michael?
Negative 8.
Negative 8. And number 4, third tries the charm, Genesis? Ooh. Negative 8. All right, so let's take a look at these together. Genesis, let's take a look at number 2 very quickly. We had 7, negative 16 times 2 plus, and then the 2, negative 3 should have just been a negative 1. Right, times 14. So I'll go ahead and simplify the parentheses as I'm copying it down because I'm lazy. I've got a multiplication here and a multiplication here. Don't touch the subtraction or the addition. So we're going to keep the 7 minus, we're going to keep the plus. What are we going to multiply right here, Genesis? 16 times 2, 32, right? And then here the negative 1 times 14, negative 14. So I've got a positive 7 minus a 32, or we could say plus a negative 32, plus a negative 14. I'll combine these to get a negative 46, put that with a positive 7, and that's where we get the negative 39. Looking at number 3, above the fraction bar, we've got a 9 minus 1.
Oh,
8. Below the fraction bar, we've got a 2 times 3 minus 2. We'll do the multiplication first to get minus 2 is 4. Plus, and then in the parentheses, we've got a 2 minus 2 times 2. But we have to do the 2 times 2 first. Then 2 minus 4. And then we're going to square the negative 2 here in just a moment. And then minus the 2 times 7. We can do this exponent real quick. What do we get when we square a negative 2? Positive 4, good, because negative times itself gives you a positive. So we have a positive 4 here. Here we get negative or minus, or you multiply 2 times 7, 14. And then here we've got the 8 divided by 4 is 2. So it's a positive 2, a positive 4, and a negative 14. We'll combine the 2 positives to get positive 6. Put that with the negative 14 to get negative 8. Remember, signs different, subtract, keep the sign of the greater. Number 4, Noah, above the fraction mark, we have a 7 minus 2 in parentheses, which gives us 5. And then let's go ahead and square that times the 2. So I'm going to do all of that first stuff in my head, just following order of operations. The parentheses, then the exponent, then the multiplication. All over 25, I might do that in my head too. Minus 6 plus, and then the 2 squared. I'm not going to write 2 squared. I'm just going to get 4 times, and then in parentheses, the 1 minus 2. Negative 1. All right, so I've got a division and I've got a multiplication. When we divide, we get 2 minus 6. And then here, when we multiply, negative 4. So we could say plus negative 4. We can just say negative 4. So it's a positive 2 and then 2 negatives. We combine the negative 4, negative 16, negative 10. Put that with the positive 2 to get negative 8 for our answer there. Anyone need to see number 1 worked, or are we all good on 1? Any questions, number 1? All right, so just little things. Genesis had a few problems with these ones. Did you find where your mistakes happened as we went over them by any chance?
On the first one, I had got to the last part with the 7 plus, and then I guess I was kind of...
Okay, the signed number. So remember, my strategy is group like signs together to get a single positive sum and a single negative sum. In this case, the 2 negatives give me the negative, 46. Then all the positives, all one of them, right, give you the positive 7. Put those together in a subtraction to get your answer. Same thing I did here. I put the 2 positives together, then put it with the negative. Get the 2 negatives together, then put it with the positive. Just cuts down on mistakes. But again, it's been a little while since we've done any of that, so that's why we're reviewing here at the beginning of Algebra 2. All right, any other questions on the first 4? All right. Rewriting expressions using the commutative property. What does commutative mean anyway, Maddie? Right, you switch the order of things. So how did you rewrite number 5 using the commutative property? Say that again? Okay, there we go. Put the C at the beginning and then add the quantity 4a plus b, or within the parentheses. Maybe you could flip it around and say b plus 4a plus c. Either of those would have worked. How about number 6, rewriting using the commutative property of multiplication, Abby?
K times quantity of negative 7g plus h.
There we go. Put the k at the beginning, before the quantity is negative 7g plus h. What about number 7? Again, commutative property of multiplication, Kendall.
In parentheses, wy and then t.
Good. Put the t after the parentheses wy, or within parentheses maybe yw. Let's see, associative property of addition for number 8, Michael.
9r plus the quantity of s plus v.
Good. Instead of grouping the 9r and the s, group the s and the v together. And leave the order alone. How about number 9, Genesis?
I put the C, D in parentheses first and then the A.
Well, that would be commutative, right? Because instead of A, C, and D in that order, you flip-flop and put the C, D first and then the A. Associative doesn't flip anything. It keeps still the A, then the C, then the D. But instead of grouping C and D together, maybe group the A and C. So parentheses around the A, C, and then leave the D at the tail end. And then number 10, the distributive property, which we're going to look at today in a little bit more detail. Dylan? All right. Brandon?
I don't want to answer now.
You don't get a choice. Answer anyway. The number dictatorship?
Yeah. GQ plus GM.
GQ plus GM is correct. Questions on those properties? I call you Dylan. I'm just kidding. Just Brandon. I do have, in my Algebra 1 class, though, Dylan's in the same spot you're in, just that front corner seat. I got to move him so that way Dylan's over there and Brandon's over there. You don't even look that much alike. I don't know. Anyway, number 12, raising to a power. What did you get for your answer, Audrey?
64y.
Good. 64, because 4 cubed doesn't mean 4 times 3. What does 4 cubed mean, class? 4 times 4 times 4, right? And then when we raise a power to a power, class, we multiply the exponents. There's our y to the 6th. Number 14, dividing some like bases, Noah.
Y to the 5th. And I think that's a z.
I think that's correct. Y to the 5th z. Number 16. What did you get for your answer on that one, Abby?
27, that's either v or y
It's a v squared, yep.
27v squared over p to the 8th c to the 16th.
Now, just a word of caution, remember, when I grade your stuff, I better know what it is, because otherwise you'll be like, it looks like a v or a y. There's no y's in the problem, but I'm going to assume she means a y minus 10. You don't want that, so write very clearly so there's no question, so I can't be mean. 27v squared over p to the 8th, z to the 16th. Remember, we do subtract the exponents when we divide like bases. And if the bigger power's in the bottom, when we subtract, leave the answer in the bottom. Good job, Abby. Number 18, Maddie.
H to the 8th, k to the 6th, and to the 8th, k to the 4th.
There we go. H to the 8th, k to the 6th, m cubed over w to the 4th. Got some negative exponents to play around with here, and it says they don't want any negative exponents, so if it's got a negative exponent, we've got to, class, move it. Take the reciprocal. So if it's up, move it down. If it's down, move it up. The other place, right? Number 20, Audrey.
A squared over b y to the 5th z cubed.
Good. A squared over b, y to the 5th, z cubed is correct. Number 22, Genesis. Got a part of it right, but a few parts wrong. There's a few things going on here. Dylan? Look what you made me do. Brandon! I'm just going to point at you and say, you! I can't use last name. I was going to use last name. I can't even do that because we're recording.
A to the 4th over m to the 15th p squared.
A to the 4th and over m to the 15th p squared. I'm going to get it right, Brandon. You hang in there. I was going to get Don't worry, Dylan. I'll get it right next time. Brandon. I'll start calling him Brandon. How about that? Would that make you feel better?
No.
Who's older, you or Dylan?
Him by a minute, but he acts like he's doing a job.
Oh, well, you know, hey, at least we're opinionated. All right. So you love your twin brother. All right. Just a little. Yeah, do you have a microscope? No, that's upstairs. Number 24. My Bible says love one another. It didn't say how much. It just said, well, it did actually, as I have loved you. There's a sermon in there. We got to move on. We don't have time to preach. Number 24, Kendall.
A to the 4th over b to the 6th, c to the 13th, d to the 4th.
Good. A to the 4th over b to the 6th, c to the 13th, d to the 4th. I did want to take a look real quick at number 22. We have the a, m to the negative 8th, r to the 5th. That's an r. R to the 5th, remember right clearly, over a to the negative 3rd, m to the 7th, p squared, r to the 5th. All right, so first thing I see is that the r to the 5ths are perfect matches. No matter which direction you try to subtract, 5 minus 5 class is 0, and anything with 0 power equals 1. So it cancels away completely, basically. I then see that there's no friends for the p, so the p squared could just stay at the bottom in my answer. I see, though, that there are two a's, but one of them has a negative exponent, and it's got to move up, Genesis. When it moves up, it becomes, right, so a cubed. But there's also an a to the 1st up here, and now that they're together, they have to be multiplied or divided. Multiplied. So when I multiply, when I multiply like bases, add the exponents to get a to the 4th. The other way you could think of it is you could subtract 1 minus negative 3. When you subtract a negative, it adds a positive. I think moving it is the easier, more consistent way to think of it, but either way works. So if we do the same thing, moving the m to the 8th, or negative 8th, down as an m to the positive 8th. Now again, they're together, so I have to multiply, so I have to add the exponents, and that's where we get the m to the 15th. Does that make sense? So just move it and then do what the exponent says, rather than trying to think through, wait, 7 minus negative 8 or negative 8 minus 7. I think that's a little harder. I think the easier way is move it and then let the multiplication take over. Was anyone perfect on those last 7 problems? Okay, a couple of you were. How many of you just missed one? I just missed one. All right, I went over the one Genesis missed. The rest of you missed one. Do you need to see it worked out, or have you already figured it out? Any questions? Going once on questions. Twice on questions. Gone on questions. All right, next section, your notes. Adding polynomials. Adding polynomials. First thing you need to write down under adding polynomials, which polynomial, remember, just refers to an algebraic expression that consists of terms. So we're adding terms together. Adding polynomials, which sounds so much cooler than adding terms, sounds mathy. Write this down, you can only add like terms. You can only combine, I should say, like terms. And it's something you learned in probably 7th grade. So it's been a few years that we've gone over and over and over. So it should be good, but we want to refresh our memory anyway. Only combine like terms. And remember, by like terms, the literal coefficient, that means remember the letter part of the terms, have to match. So for instance, a 6x squared and a 3x squared, their letters completely perfectly match. And since they perfectly match, we can add them. Remember, when we add, we only actually add the numbers together. 6 plus 3, class? 9. And we keep the x squared. It's as if, imagine an x squared being a thing, like an actual object called an x squared. And imagine you have 6x squares in one hand. I don't know if you could hold that many. And 3x squares in the other one. I'm sorry. I'm kind of sorry. 3x squares in the other hand, you would have 9x squares. You wouldn't have, the x squares don't change it to some other thing. There's still just 9 of those things in your hand. So if I had a 7xy cubed, negative 12xy cubed, are those like terms, class? Yeah, so they can be combined. Now, they have different signs, so we have to apply the sign rule, but what would we get when we combined right here, Noah?
Negative 5xy cubed.
Good, combine the 7 and the negative 12 to get negative 5, and then keep the xy cubed. If I had a negative 2a and a positive 5b, are those like terms, class? So I can't combine them. So what do you get when you try to add a negative 2a and a positive 5b? That. It's your answer. You can't do anything with it. But we'll also see, though, are expressions like, for instance, a 4ab, negative 3c squared, positive 8c squared, positive 2ab, where there's an assortment of terms, but some of them are like. They're not all like to each other, but 4ab, for instance, class, is like to the 2ab. And we combine those, Michael, we get
6ab.
6ab. The negative 3c squared and the positive 8c squared. Well, those are like to each other. We can combine those, Genesis, to get Well, careful, signs are different. So do we add or subtract? Subtract. Keep the sign of the greater, we get. There we go, the positive 5c squared for our answer. Do we remember going over all of this? Is it coming back to us now? Again, for some of us, it's been a couple years. You know, we had geometry between Algebra 1 and this. Some of you, coming off it from last year, questions. All right, look at page 9 in your textbook. Flip back to page 9 at the bottom of the page. And here there are some polynomials grouped together in parentheses. And you might recall that when we said we've got parentheses, if the parentheses have a positive sign in front of them, they literally just disappear. So if there is a positive, you may want to jot that in your notes if you've forgotten that, but if there's a positive in front of parentheses, the parentheses can just fall off. So notice, the given problem is parentheses around negative 3x squared, negative 6x, positive 8. And the next step, you have the same thing, but they ain't there no more. Look at the next polynomial. Grouped together is the 8x squared, positive 7x, negative 14. And then they're not there anymore. Because if you have a positive, even an understood positive in front of parentheses, they just disappear. And then you can combine your like terms. Notice they combined the negative 3x squared with the positive 8x squared. When they did, they got a positive 5x squared. Subtract, keep the sign of the greater. Notice they combined the negative 6x with the positive 7x. Signs are different. Subtract, keep the sign of the greater. Positive 1x or just positive x. Notice they combine the positive 8, which has nothing with it, no letters. Well, that matches the negative 14 that has no letters. They're still like terms. Subtract, keep the sign of the greater, get negative 6. Questions on this? Remember combining like terms. All right, page 14, do numbers 1 and 2. Page 14, do numbers 1 and 2. Audrey, Michael, Ken. Brandon. I was waiting, but I'm Maddie. All right, let's take a look at these together. Number 1, what did you get for your answer, Brandon?
33x squared plus 2x plus 7.
Good. Or you could say 33x squared, positive 2x, positive 7, plus positive, doesn't really matter. Number 2, what did you get for your answer, Maddie?
6y squared plus 7y plus 2.
Good. 6y squared, positive 7y, positive 2. How many got both of those correct? Are there any questions on combining like terms? Abby, question? All right. Turn back, or next section of your notes rather, subtracting polynomials. Talked about addition, feel like we're good there. Subtracting polynomials. By the way, the abbreviation for polynomial is P-nom. Okay, P-nom means polynomial. I'm lazy. Shorthand. Those in geometry will recognize shorthand. Okay, or you could write out the word polynomials, but I don't. First thing to write down is we never really subtract in algebra, right? What do we do, class? Add the inverse. Thank you, Noah. Add the inverse. So anytime we are instructed to subtract, we don't do that here. We add the inverse. What does that mean? Change every sign after the subtraction. You'll want to change every sign after the subtraction. So for instance, if you see minus and they give you some polynomial, maybe there's a negative here and a positive here and a positive here and a negative there, whatever. When you see a subtraction, we don't ever subtract, class. We add the inverse. So instead of a negative, it becomes a positive. Instead of positive, a negative. Instead of a positive, a negative. Instead of negative, positive. We change all those signs after the subtraction sign. Once again, though, we still only combine like terms. Still only combine like terms. And if you think about it, since subtraction is adding the inverse, we're really doing what we just did, right? Adding polynomials, we're still adding polynomials. We're just calling it subtraction, but we're really adding the inverse. Turn to page 10. Turn to page 10. We'll look at the top of the page. Notice it says find the difference between the polynomials. Of course, we know difference means subtract. Notice what they did. Do you see how there's an understood positive? Actually, you don't see literally, but you understand there's an understood positive in front of the first set of parentheses. The fact that you see no sign means it's a positive. So, parentheses gone. X squared positive x negative 5, nothing changes. Now look, the 3x squared, you don't see a sign in front of the 3x squared, you see a parenthesis. But if you wanted to, in your book, you could carefully put in a tiny little plus sign, a positive sign. So when they copy down the 3x squared, what was a positive, notice in the line below it, becomes a negative 3x squared. Notice where they had the positive 7x, it became a negative 7x. Where they had the negative 14, became a positive 14. So as the parentheses disappear, the signs change. We remember this from past years. All right, then they just combine like terms. So the x squared and the negative 3x squared, negative 2x squared. Positive x, negative 7x, negative 6x. Negative 5, positive 14, positive 9. Notice descending order in the polynomial. Highest power, lower power, descending. Questions on that example? We remember this? Not teaching anything new here, hopefully. Because I'm not teaching it like I'm teaching it, I'm reviewing it. All right, do numbers 5 and 6, back on page 14. 5 and 6. Change every sign, including that first sign. After the subtraction, because we don't really subtract. We add the inverse. All right, number 5, Genesis. What did you get for your answer?
12b squared plus 12b plus 3.
All right, you treated it like an addition problem, right? You added everything together, but you didn't add the inverse. So help me here, Genesis. Let's copy it down. How do I copy the first set of parentheses, but without the parentheses?
Negative 8.
Do I change the sign on that first set of parentheses? See, there's not a negative in front of the first set, so let's just keep everything the same.
8b squared plus 7b plus 2.
But notice the next set of parentheses has a negative in front of it, or a minus in front, so we're going to change everything we copy down now.
Negative 4b squared, negative 5b, negative 1.
There we go. So now as we combine Genesis, it's 8b squared and negative 4b squared.
4b squared.
Positive 7b, negative 5b. Positive 2b. Well, no, careful, we don't, not square, just 7b's and we take away 5b's, we still have 2b's like in a beehive. And then positive 2 and negative 1. Positive 1, and that should have been our answer. Does that make sense? All right, and then number 6, what did you get for your answer, Abby?
Negative 8b squared plus 7b plus 4.
Negative 8b squared, positive 7b, positive 4. How many got both of those correct? All right, in Genesis, it makes sense now? All right, any questions from anyone else? Any questions? All right, next thing in your notes. We're moving really quick here. Distribution. We addressed the distributive property a couple days ago. Let's talk about distribution now. Distribution is multiplying a monomial by a polynomial. It's where we apply the distributive property. Distribution is multiplying a monomial by a polynomial. For instance, we might have something like a 3x squared y to the 5th monomial. by, let's just say, a polynomial negative 8x cubed plus 2 minus 7y. I don't know. All right, monomial, polynomial. We know they're being multiplied because there's nothing in between them, right? Multiplying. Remember when you multiply, the distributive property says you have to multiply this by this term, and you're going to multiply it by this term, and you're going to multiply it by that term. So you're multiplying 3 different times. Quick refresher from your Algebra 1 days. When you distribute, when you multiply in general, 3 steps, they are sign, number, letters. Sign, number, letters. What's the rule about multiplying signs together, Noah? Let me help you out. If the signs are the same, there's something, or if the signs are different, there's something else.
The signs are the same.
Right, if the signs are the same, you automatically get a positive, but if the signs are different, automatically get a negative. All right, remember that now, coming back to us? All right, as far as the number, just multiply. That's the symbol for multiply. Okay, also means product, but here we're using it to be multiply. Just multiply. And then as far as the letters, because we are multiplying, if you multiply like bases, class, add the exponents. So maybe jot out a little reminder, add the exponents. And EXP will be our shorthand for exponents. Geometry dies hard. Again, this is me in geometry last year. We abbreviate everything. We barely write out any full words because we're just that lazy. All right, so if we're going to distribute here, sign class, number, 24. Now, we can't do all the letters, but the x's can at least multiply. X to the 5th, remember, add the exponents. And the y has no friends, but it doesn't not exist, right? So we still have y to the 5th. Then we're ready for our next distribution. Sign, number,
6.
and now there's no friends for the letters, but they still exist, so we copy them down. And then we come to the next. Sign, number, letters. Good, the x squared has no friends, but the y to the 5th and y combines for a y to the 6th as we add the exponents. Remember all of this from our algebra days. Good. Flip back to page 10. Flip back to page 10. Look at the middle of the page. Look at the monomial times the polynomial there. Notice descending order if you can do it. This didn't really have much of a descending order to it, but descending order if you can do it. You distribute sign, number, letter. Notice they distribute it negative, number, 15, letter, x to the 4th. Then again, sign, positive, number, 24, letter, x cubed. Then again, sign, negative, number, 3, letter. Just keep the x squared because it has no friends. Questions on that? Remember it? All right. Go to page 14. Page 14, and look at number 4. Look at number 4. It looks like an addition problem, but you notice how there's a number in front of the first set of parentheses? That means before we can do any addition, order of operations says we have to multiply. So Michael, let's distribute, on number 4, let's distribute the 4 through the first set of parentheses.
4y squared, 8y.
Positive 8y.
Minus 12.
Good, or negative 12. And then we also need to distribute the positive 3 to the next set of parentheses. Kendall.
3y squared. Positive 3y.
Are the signs the same or are they different?
Different.
So it is
Negative 3y.
negative 3y.
And positive 8.
Ooh, careful, you're multiplying. 3 times 5, 15. There we go. All right, and now we just combine the like terms together, right? So distribution happens first, and then we can combine like terms. When we combine the y squares together, class? 7y squared. Signs the same, just add and keep the sign here. Signs are different, class.
5y.
Positive 5y. Subtract, keep the sign of the greater. And then same thing there.
Positive 3.
Positive 3. Keep the sign of the greater. The positive 15 wins out. Questions on number 4. Questions on 4. All right, look at number 8. Same type of thing. We're going to distribute the 5 through the first set of parentheses. Audrey.
5r squared plus 100r minus 15.
All right. And then we also need to distribute the negative 7. That is not a 7. That is a negative 7. So distribute the negative 7 all the way through the second set of parentheses for us. Brandon.
Negative 21r cubed. Yeah, positive 14R and then a negative 70.
Good job there. Do we see how we combine with the signs? If the signs are the same, negative times negative in the middle gives us the positive. The other two times it was negative times positive, signs different. Got the negative. Any questions there? Now we just got to combine like terms, but notice the highest power, if we're wanting to keep descending order, has no friends. So class, we just keep negative 21R cubed. Thank you, whoever that was in that corner. Notice the next highest power, class, is the R squared, but again, no friends, so plus 5R squared. Let's see, the next highest power, of course, are the plain old R's. There are a couple of those. Those combine to give us what, Michael?
114R.
114R. And then we got a couple plain old numbers. Same signs, class. We get negative 85. Questions on distribution. Then, of course, combining like terms perhaps after a distribution. Any questions on that? All right, I want you to do numbers 3, 7, and 9 through 12. 3, 7, and 9 through 12. Three, 7, 9 through 12. Good, Dad. Audrey, Noah. Not finished after all, Abby?
Nope. All right, for sake of time, let's take a look at these answers together. Number 3, what did you get when you distributed and then combined like terms together? Kendall? 5n squared minus 30n plus 7.
Really close. Michael Helper?
I got 5n squared minus 33n plus 5.
Ooh, also close. But you got what she missed, you got right, but one of the things, anyway. Let's see here. Let's see if Genesis can help you out. Number 3, Genesis.
5n squared plus 7n plus 7.
No. Maddie.
5n squared negative 33n plus 7.
There it is. 5n squared negative 33n positive 7 is correct. How many got that answer for 3? All right, so let's check the work here. When you distribute the 2, you got a negative 10n squared, negative 6n, positive 4. Then distribute the next, you get positive 15n squared, negative 27n, positive 3. All right, so you 3 who had missed it, did you get the initial distribution step correct? So your problem was in the combining, you missed the distribution.
I added. Well, not added, but I got negative 3n squared instead of negative 10n squared.
Oh, right here, instead of multiplying the 2 times 5 to get 10, you added for some reason, got the 3. Okay, gotcha. All right, and then from there we'll combine the like terms. So again, there's the positive 5, there's the negative 33, there's the positive 7. All right, for redemption, Kendall, what did you get for number 7?
2c squared minus 15c plus 10.
Just a little bit off again. All right, Michael.
2c squared minus 18c plus 10.
There we go. Okay, so 2c squared negative 18c positive 10. Check your distribution, Kendall. 6c squared negative 24c positive 12. Negative 4c squared positive 6c negative 2. Was that a mistake, or you say, no, I got it?
I got it.
You got that, so it was the combining step. Okay, did you already find your mistake? That middle term, the plain old 6, the negative 24c and the positive 6c should have given us a negative 18c. All right. How many got number 7 correct? Did you go on 7? All right. Then numbers 9 through 12. Let's go, Audrey, number 9.
3x squared minus 2x squared plus 7x.
Your first term would have happened to be a 3x cubed, would it?
Yeah, it is.
It is. You just said squared. Okay. 3x cubed to negative 2x squared, a positive 7x is correct. Number 10, Genesis.
8x to the 4th plus 20x cubed plus 4x squared.
Good. 8x to the 4th, positive 20x cubed, positive 4x squared. Number 11, let's go over to Abby.
24x to the 4th negative 16x cubed plus 8x squared.
Great job. 24x to the 4th, negative 16x cubed, positive 8x squared. And number 12, Noah.
Negative 40x to the 4th, negative 30x cubed, positive 200x squared.
Good. Negative 40x to the 4th, negative 30x cubed, positive 200x squared. How many got the last 4 all correct? Didn't go 4 for 4 on the last ones? All right. Any questions at all? Distribution. Any questions there? All right. Turn over to page 19. Page 19. Let me have you go ahead and do numbers 9 through 12. Page 19, numbers 9 through 12. Check that. Let me give you your homework assignment, let you get started on your homework. I'll make this part of your homework. Your homework for this evening, we're going to end here. Your homework for this evening, first of all, study section 1.1. Study section 1.1. There's a lot in section 1.1. Okay, algebraic representation, order of operations, operations involving exponents. There's a lot of stuff in there. Numerical evaluation. So study section 1.1, you will have a quiz tomorrow over that in our next lesson. And then page 19, do numbers 1 to 12. Page 19, do numbers 1 through 12. That'll obviously include the 9 through 12 you were just starting on. So got a little bit of a head start there. That's fine. And you'll have the rest of the hour to work on your homework. Page 19, numbers 1 through 12.